Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, find the value of the constant b such that the function f at x equals square root of x plus 1 plus b over x has a point of inflection at x equals 3. Now, at point of inflection, the second derivative of the function is equal to 0. So we have to find the second derivative of this given function. Now, this function is made up of a radical term, square root of x plus 1, and then the rational term b over x. So the first step is to modify this equation so that it becomes easier to find the derivative of this function. So we should change the radical into a rational exponent, and in the rational term b over x, we should move the x to the numerator. So our first step is f at x equals, so we can change the radical into a rational exponent 1 over 2. And in the second term, we can move the x to the numerator and its exponent becomes -1. Now we can find the first derivative of this function. So for the first term, we'll have to use the chain rule because this term has an inner function x plus 1, and then the outer function is the exponential function with exponent 1 over 2. So we start with the derivative of the outer function. So for that we'll use the power rule. So we can move the exponent 1 over 2 to the front. And we subtract 1 from the exponent. Times the derivative of the inner function. And the inner function is x plus 1. So the derivative is 1 plus 0. 1 is a constant, so that's why its derivative is equal to 0. Now we can move on to the second term. Now b is a constant and it's a coefficient of the term, so it will stay as it is. And for x exponent -1, we can use the power rule. So we'll move the -1 to the front and subtract 1 from the exponent. Now we can simplify this expression. So in the exponent, half minus 1 is equal to -half. And 1 plus 0 is 1, and multiplication by 1 doesn't change anything. And in the second term, b times -1 is -b, and the exponent on the x is -2. Now we can find the second derivative of f at x by finding the derivative of this prime of f at x. So in the first term, 1 over 2 is the coefficient of the term, so it will stay as it is. So for x plus 1 exponent -half, we'll have to use chain rule. So we'll start with the derivative of the outer function. So we'll move the exponent to the front and subtract 1 from the exponent. Times the derivative of the inner function, which is x plus 1. So its derivative will be 1 plus 0. Now we can move on to the second term. So negative b is the coefficient, so it will stay as it is. And for x exponent negative 2, we should use the power rule. So we can move the exponent negative 2 to the front and subtract 1 from the exponent. Now we can simplify this expression. So in the first part, half times negative half is negative 1 over 4. And then in the exponent, negative half minus 1 is equal to negative 3 over 2. 1 plus 0 is 1, so multiplication by 1 doesn't change anything, so it goes away. Now in the second part, negative b times negative 2 is positive 2b. And then exponent of x is negative 3. Now we can move the x terms to the denominator to make their exponents positive. Now we are given that the function f at x has an inflection point at x equals 3. So that means the second derivative of the function at x equals 3 is equal to 0. So in the next step, we'll sub in the left side as 0 and x as 3. So we can do the step on this side. So we get 0, the negative 1 over, so we have to sub in x as 3. And then plus, now we have to solve this equation to find the value of b. So the first thing we can do is to simplify the denominators in these fractions. So 3 plus 1 is 4. And 3 cube is 27. Now we have to simplify 4 to the power 3 over 2. So I can show you the steps on the side. So 4 exponent 3 over 2 can be written as square root of 4 cube, because 3 over 2, so I can show you the can also be written as 4 exponent 3 and then the outer exponent 1 over 2, and then exponent 1 over 2 is basically square root, and then we get 4 cube under the square root, and 4 to the power 3 is equal to 64. So it's basically square root of 64, which is equal to 8. So that means in the next step, we can rewrite the fraction as 0 equals negative 1 over 4 times 8. Now we can multiply the numbers in the fraction. So 4 times 8 is 32. Now we can move the fraction negative 1 over 32 to the left side, and that will make the fraction positive. Now we can cross multiply the denominators. So we can cross multiply 27 to the left side and 32 to the right side. So we get 27 times 1 equals 2b times 32. So 27 times 1 is 27, and 32 times 2 is 64b. Now we can isolate b by dividing both sides by 64. So 64 on the right side get cancelled out. So we get b equals 27 over 64. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.